Welcome friends. In this video we are going to focus on some questions from section B of science paper 1 for the year 2023, and this paper was written by the external candidate. So let's have the first question. A learner carried out an experiment and obtained the following results as shown. Where necessary, take the density of water equal to 1 gram per cubic centimeter. So we have been given the density of water, which is 1 gram per cubic centimeters. Now let's look at the first point. So the first point here, we can see the mass of an empty bottle. So before any liquid was poured here, it gave the result of 8 grams. So this is the mass of the empty bottle. Then the mass of the bottle full of water. So after water was put in this bottle, the mass readings showed 20 grams. Then there was another liquid, which is liquid X, which gave the reading of 25 grams. So question A, name the instrument that can be used to obtain the results of mass. So this question is same as we want to look at the instrument that can be used to measure mass. So this is a beam balance. Then for question B, calculate the volume of the bottle. So for the bottle, we only have the mass. We don't have the density. So what can we do? So if we have a bottle like this, okay, so this is our bottle. So if you look at the volume, and if you define volume is defined as the total amount of space occupied. Right, so the volume inside the bottle is equal to the volume of water. So if we pour water here, this water will occupy the volume of, so we'll have the volume of water. So if we can find the volume of water, we'll be able to find the space of this bottle. So let's find the volume of water. So what can we do here? So let's look at the formula for density. We know that density is equal to mass over volume. So over 1 we cross multiply, which is density times volume is equal to mass. So over density over density. So whenever you are given mass and density, to find the volume is equal to, you get the mass, divide it by its density. Or I don't know if you are able to remember this triangle. This triangle can help you to remember, where here we put mass, then volume, and here we have density. So if we want mass, you multiply volume times density. If you want volume, it's mass divided by density. If you want density, it's mass divided by volume. So you can use this to help you remember. So let's have this question. So we know that we want volume. So volume is equal to mass over density. So can we find the mass of water? Yes, we can find the mass of water. So let's look at this point. So the mass of the bottle full of water is 20 grams. So in this 20 grams, there is 8 grams of an empty bottle. So we need to take it out. So 20 grams minus 8 will give us 12 grams. So the 12 grams is the mass of water. What of the density? Density is given, it's 1 gram per cubic centimeter. So we can cancel this, which is our volume of water is equal to 12 cubic centimeters. Remember, this is the volume of water. So the volume of water is equal to the volume of the bottle, because this water occupied the space found in the bottle. So we'll say 12 cubic centimeter. So if this is water, let's look at the same bottle, but this time instead of water, let's say we put another liquid in this same bottle. So we have liquid X. Now the question that I want to ask you is, if we put this liquid X into this bottle, will the volume of the bottle change or not? So the answer is definitely no. The volume of the bottle will not change. The volume of the bottle will still 12 cubic centimeters. So if the volume is the same, this means that the liquid X occupied the same volume that was occupied by water. So what we are saying is we have the volume of liquid X. Since from the table we can see that if we want density, we need to find mass over volume. So from this we can see that we have the mass, the density, sorry, the volume, we have it 12 cubic centimeters. What of the mass? Let's go back to this point. So the mass of the bottle full of liquid X is 25 grams. So we subtract the 8 grams for, so we subtract the 8 grams for the empty bottle. So what do we get here? So we get 17 grams. So this is what we are going to put here, 17 grams. Then the remaining part here is just to do the math. So 17 divided by 12, I'm getting 1.42 grams per cubic centimeter. So if we leave our answer correct to 3 significant figures, this is what I'm getting according to my calculator. Okay, so we move on to question 2. So figure B2.1 shows the same cone being placed in 3 different positions, X, Y, and Z, on a flat surface. So then the tip of the cone resting on the surface. So we have X cone laying on the surface. Okay. Then the first question is define the center of mass. So what is the center of mass? And let's see if we can maybe create a picture here. So let's say this is let's try to use the seesaw principle here. So let's say we have a meter rule. Then we are not going to hang any weight on this one, but we just consider this meter rule is balanced. So remember, this object has a certain mass. So let's say it has 100 grams. So if at this point is where this meter rule is balancing, it means that the whole mass of this meter rule is acting on this point. So on this point, it means there is no mass. Even here, there is no mass. So the whole 100 grams has gone to one point. So that point, whenever you place an object at its center of mass, it is going to balance. So the center of mass is just the point where the mass of an object seems to act. So say this is the point. In or on an object where its entire mass seems to act. Now identify the cone in a neutral equilibrium. So a neutral equilibrium is where if you try to push something, it just roll down, it doesn't fall or go up, or it's just like roll in a certain direction. So let's look at the X. So let's say we push this one here. So if we push this one, we are expecting it to fall down here, and it can't go back to its original position. So this is unstable. Then for this one, if we push it here, we are expecting this one to roll maybe to a certain position like this. So we can see that Y is neutral. Then for this one, if we apply a certain force, because the base is greater than this one, it will just move a bit, then it goes back to its original position. So this one is stable, so it's cone Y. So say cone at position Y, it's where we have neutral. Okay, then set two factors that affect stability of an object. So the first one, we'll look at the size of the base of an object. So I want you to have a picture. Let's maybe see if we can create a picture. Let's say a person is standing. So this person is standing, and this person, he or she has his feet closer to each. Then we have another, okay, the same person moves to a certain position. Now he or she spreads the legs wide. So if this point, if this person is pushed, this one is easy for this one to fall down compared to this one. Why? If a person spreads his legs or her legs, then the stability increases. I'm sure you can see the picture that I'm trying to create here. So that is what it means by the size of the base. Then the second one, we'll look at the height. So the height of the object. It's easy for someone who is taller to fall down compared to someone who is shorter. Then we move on to question 3b. 3.1 shows the direction of flow forces acting on a car whose weight is 8,000 as it travels in a horizontal straight line. So the force C is weight, and we are given weight to be 80,000. Then this one should be a normal force. A normal force is parallel and the opposite to the weight force, and the normal force must be 800, because we can see that this one is stationary. It's neither moving up or down, so the two forces must be equal in opposite direction. Now we have force B. So let's say this force B is produced by the engine. Okay, then this one we can just say it's a friction force. Remember, the friction force opposes the movement, the forward movement. So which two forces should be equal for the car to move at constant velocity? So let's see. So let's see if we have constant velocity. So we are saying velocity which is constant. Now there are conditions that you need to know for this to be achieved. So what are we supposed to do? So we know that the net force must be equal to 0. Then the acceleration must also be equal to 0. So whenever we have an object moving with a constant velocity, the net force is equal to 0, the acceleration is equal to 0. Why do we so? So let's say the driving force is 200 newtons. So how can we produce a friction? What is the friction in such a way that this vehicle is moving with a constant velocity? So let's look at the formula. So net force will equal to, we'll say, force produced by the engine subtract by force produced by the friction. Why are we subtracting? Because these two forces are pointing in different directions or in opposite directions, so we need to subtract. Now remember, for a constant velocity to be achieved, the net force must be equal to 0. So let's say where there is net force, we put 0. Then the force produced by the engine is 200 newtons. Then the friction force is what we are finding. So if we shift this to the left side, we get negative 200 newtons, which is equal to negative F. So we divide by negative, also by negative here. So the friction force must also be equal to 200. So here we need to have a 200. So these two numbers, I just use them so that I can give you a picture. So the point is, whenever you have two forces pointing in a different direction, or in opposite, not in different but in opposite directions, the net force will be equal to 0. If that object is moving, then the acceleration must also be equal to 0. Therefore, the velocity will be constant. So which two forces should be equal for the car to move at constant velocity? We'll say it's force B and force D. Then we move on to question B. The following table B3.1 shows sizes of forces acting on the same car after it had covered a certain distance. So take gravity as 10 newtons per kg. Force A is 800, force B 1000, force C 8000, then our D is 600. So calculate the mass of the car. So we can't use the second law of motion since we don't have the net force here and the acceleration is not given. So what can we do? So remember, we have the weight of this particular vehicle. So the weight, which is force C, if you go back, is 8000. So how can we find the mass using weight? So say we know that the formula for weight is equal to mass multiplied by gravity. So if we divide by gravity, also here by gravity, this will say mass is equal to weight over gravity. So what's our weight? Our weight is 8000. Where is this 8000 coming from? We have been also given here. So remember, whose weight is 8000. So the weight is given. So weight divided by the gravity will give you the mass. So over 10 newtons per kg, which is, if you divide this, you get 800 kg. So this was the mass of this particular vehicle. Then for Roman number 2, resultant force on the car. So let's look at D is 600. So D is 600, and remember D is considered as the friction. Then B is 1000. 1000 is being considered as the driving force. So how can we find the resultant force? So we are going to find a difference between these two numbers. So since they are pointing, so say net force is equal to the forward force is 1000 newtons minus 600 newtons, which is giving us 400 newtons. So whenever we have a resultant force greater than 0, then the acceleration is there and the velocity is not constant, it's now changing. Then how can we find the acceleration? So the acceleration, we are going to use now this one. So net force is equal to mass by the acceleration. So let's divide by m, also by m. So the acceleration is net force over mass. So the net force is just 400 newtons. Then the mass, remember, the mass was calculated as 800 newtons. So if we do this, we get 0.5 meters per second. Now, how can we maybe see if we can add some more spices for this one? So for an object to move to a certain point, if we need to move in this direction, we need to make sure that we apply a certain force that must be greater than the opposite force, which is the friction or the drag force. So if we're able to produce that force that is greater, then an object will be able to move. Now, if you look at the formula from the second law of motion, force is equal to mass times acceleration. So the acceleration depends on the size of the mass. So if the mass increases, the acceleration decreases. So mass is inversely related to acceleration according to second law of motion. So if, for example, we have an object of let's say 10 kg, then another one of the same 10 kg, 20 kg. We want to have two objects of the different mass. Now let's say we want these two objects to produce an acceleration of 0.5. So what force is needed to produce, what force is needed to be applied on a 10 kg object to produce this one? So let's find by calculation. So net force is equal to, the mass is 10 times 0.5, which is this one will just give us. So to produce the acceleration of 0.5 meters per second on a 10 kg Newton, a force of 5 Newton is needed. How much force is needed to produce the same acceleration but the mass of 20 kg? So you do the same. So the mass this time is 20 times 0.5. So here we are going to have 10 Newton. So I want you to see the point here. These two objects have the same acceleration, 0.5, but the two forces are different. Why? Because of the mass. The two masses are different. So you can see that if you increase the mass of an object, then the force that should be applied must also increase. That's what I wanted us to look at. So the net force depends, the net force to produce a certain acceleration depends on the mass of that particular object. So for this video, we'll just end here. So that's it for this video. Thanks for watching.